So in this video, we will continue with the creation of our player script. The goal of this video is to have a very simple system that is set up so that we take user input into account, meaning that when a user goes left or right with the keyboard, meaning the A or the D key, then our player on screen here, our little yellow cube, is going to move left and right.
Sure, we're adding some gameplay elements. Right now, it's not even a game.
That's right. So this is where things are going to become interesting because we will be able to interact with our little yellow cube as a player ourselves. So right now, the only thing we do have in place is instructions that tell our cube to locate itself all the way up here in the corner when we hit play.
And here's a question
for you.
Here's a question. If you're creating a script like this on your own, do you really need to use scripting to tell your object where it needs to be when the game starts?
No, Unity is full of wonderful tools. Use those tools. I can come in here. I know I want this guy to start down here at the bottom. I'm going to just grab him, move him down, and that looks good to me.
Okay.
There we go. All I need to do is make sure that I come over here and take this line and remove it because I no longer want to tell my guy to jump to that location when start is called, so when I hit play. As a matter of fact, watch this. I don't want anything to happen as far as start goes, so I don't even need to override that function. So I can keep my script nice and clean by deleting that out, and then with that, I can hit save, not undo. I can hit Control S, not Control Z.
S and Z look a lot alike.
Yeah, they do, especially when you're not looking at the keyboard. Then I can jump back over here into Unity. Notice he's sitting down here on the floor where I physically positioned him. I can hit play. He doesn't go anywhere.
Gotcha.
He's exactly where I want him to start out at.
But the cool thing is, at this point, you've now seen the start function. So you now know that you can plug any kind of functionality you want into that, and it's going to take place at the very beginning of your game.
That's right. So now we need to get this guy to where he can move. So how do we go about doing that? Let's jump back over here. Well, in having him move, I need to give some sort of speed. I need to set a speed because he's going to move real slow left and right. He's going to move super fast left and right.
Sure.
And the way I'm going to do this is I am going to define a public data member. So it's a variable, but it's a special kind of variable in such that it is a field or it is something that belongs to the instance of this class as a whole.
Okay.
And it is what allows someone who has instantiated this class to give the instance state. Okay, so a specific state by saying that this instance of player, this script, has a speed of 5. And then if we had another player that has the same script attached, we could say this guy has a speed of 7. So their states would be different.
Okay.
So again, this is going to be a public. You'll notice that I am defining this inside of class, but outside of my function. So up here at the top. So public, now next thing I need to specify is going to be the data type. So let's just do a float. So this allows us to enter numbers that also contain decimals. And let's give it a name. I'm going to call it player speed. And let's go ahead and just terminate that. Now, by making this guy public, something very interesting happens. Let's go ahead and save and jump back over here into Unity. And boom, he just popped up. So now if we locate our player script, player speed shows up. I can come over here and I can type in a number myself. So let's go ahead and put 5 in over there.
Oh, now that's cool.
This is very helpful because now while the game is running, I can come over here and adjust my speed and find a number that I like.
See, I was figuring you'd have to go in there and actually, now that you've established your variable, now you've got to instantiate it. And
well, the variable is going to be, he is instantiated in the sense that we've already taken the script and attached it to a player. So in this case, this is our instance copy, if you will.
Right.
So we've given it state by assigning 5 to it. Now, we need to use it in some way because right now there's just a number 5 sitting out there.
It's just cool that you didn't have to plug that number in through code. You can do it within the interface.
Absolutely.
That's very wicked.
Well, it becomes, like I said a second ago, very helpful when you don't know for sure what the number is, and instead of having to jump back and forth between Unity, Visual Studio, Unity, Visual Studio, tweaking numbers out, you can just do it in the inspector.
Okay, hurry up. I want to see this.
You just want to see how this is going to play out, don't you?
Go.
Okay, so now what we need to do is we need to come up with an amount that we want to move, and we need to apply that to our game object. I'm going to jump down inside of update. Now, update is going to be run every frame, and every frame is a great place to check to see if the player is holding down, one key or the other. And notice how I paused when I said, when the player is holding down. Well, what is considered down here? I mean, are we holding the A key? Are we holding the left arrow key? Or do I have a joystick in my hand and I'm holding the joystick over to the left? Check this out. This is going to become very important in a second. Jump back over here into Unity. Let's come away from our player for a second. Come up to Edit. Let's jump down into our project settings, and then from here, let's come over here to the Input Manager. So we select Input. Our inspector suddenly comes to life with new stuff. Let's open up our axis, jump down in here, horizontal, vertical, fire 1, 2, 3, jump, mouse X and Y, all the way down, and then you're going to see stuff, some of the stuff, the more common things, start repeating again.
Right.
What we can do in here is we can come in and we can start specifying what exactly will constitute the movement of something in a horizontal key or mouse button, and which one specifically. So as we come down and we open up Fire, positive button, left control. Up here, positive button, right. Negative button, left.
Which would be arrow keys?
So if we're wanting to get, yes, a left or a right, that, well, in this case, we also have alternate. So yeah, so we can use arrows, or we can use the A and the D key for going, again, left and right. Negative meaning that when we get a value back, we're going to be going from 0 to 1 or 0 to -1. If I want to go left, now my character is positioned, I call him character, my player is positioned at 0 in X. Okay?
Sure.
So going left would be going negative.
Negative, right.
So my negative button, left, is going to be A, okay, my alternate negative, and my positive is going to be D, going to the right.
Threw me off. I was like, well, it kind of depends on which axis you're facing, doesn't it?
And then if we jump down here to the other horizontal, you'll notice we have joystick axis set up in here. Okay, so very cool in that we can come in here and we can also, there's other things that can be specified that we're not going to discuss right now, but we have all of this flexibility that we can wrap up into a single word, horizontal. Later, you'll see that when you build your game, that this information in the Input Manager right here can be made available to a player so that a player can come in here and set what will be left and right motion, what's going to be jump, etc.
Sure.
But from our point of view, from a coding point of view, it is simply going to allow us to refer to these axes as just horizontal.
Gotcha.
Then a player could later go in and say horizontal is going to be the J and the L key for whatever reason.
So for the purposes of coding, it's all left very generic.
Yep.
And we can make it specific within the editor.
Absolutely.
Okay.
So that's what we want to take advantage of here. So to do that, let's jump back over here. Now, again, I'm going to, in the spirit of Casey Jones' great videos that he put together, I'm going to follow the exact same formatting for everything, again, so that people can see the differences between C# and JavaScript. Again, a lot of this you're going to find very, very similar, if not spot on. What I need to do is I'm going to create an amount to move. How much do we need to move in this frame? So let's go and do a float variable, and let's call this amount to move. So there's the local variable that I am creating inside of update. And now with amount to move, I need to determine how much do I want to move this guy here. So I need to move by his speed. Let's just play with stuff.
Sure.
So if I say move by player speed, I haven't done anything that takes into account any type of
direction.
Yeah. So I need to get that from somewhere. So what if I took player speed and I multiplied that by something? Like what if I did input? Yep, there's input available to us inside a little drop down. And then inside of that, I come down and now I want to turn around and get some information from an axis. Remember we saw when we went to the Input Manager, we had axis that we opened up, and then we saw all of the different ones available. So let's go ahead and say get axis, but look over here to the right. It says that, well, let's see if we can get that to pop back up. It's looking for a string axis name, and we saw it was called horizontal. So let's go ahead and say get axis, and then open this guy up. And there he is. He's looking for the string name. So string, let's go ahead and throw him in double quotes. And I'm going to call it horizontal. Let's close off the quotes. Let's close this off. And that information gets multiplied by our player speed, which we've set to 5 over in the inspector. So again, what we're getting here is going to be a value that runs between -1 and 1. So if we're going to the left, we're going to get -1. Going to the right, we get 1.
Now, is that a float value where it can go like halfway in
Yeah.
between?
Oh, yeah.
So if you have like an analog stick?
Absolutely. If you have that joystick and you just barely bump it, you got it.
Okay.
So we have this. I would like to point something out, though, and that is right now we're using Get Axis. There's another one that we could use called Get Axis Raw. The difference is Get Axis is going to filter out or smooth out the result that comes back. So if you were using an analog stick, just so that we get, so nothing's nice and jerky, everything's nice and smooth. And it's going to give you the feeling of having your player almost slide on ice, if you will, a little bit. But we're going to change this in a minute. I just want to talk about the two and then show you the other one, because to me that feels more like the standard arcade games that I play.
Okay.
So we'll do Get Axis. So we get this information, we multiply it by the player speed, and now it's stored in our variable amount to move. Now we need to use it. So where are we going to use it? I'm going to use it to affect my player's position, but I'm going to use it differently than the way you guys saw a few minutes ago. A few minutes ago, you saw me manipulating the position of the player by using its transform.position property. Okay?
Right.
So we just jumped right into saying, this is where you're going to be. Now, what we're going to do is we are going to use a function that is available on transform called translate. This is a relative thing.
Yeah.
So it's going to cause us to translate from where we are based off the amount we feed in. Let me type it out. It'll make a lot more sense when you see it.
It already makes sense. I see where you're going, because translating something suggests you're moving it. Setting its position, says I want it to be right here in this spot.
In absolute world space.
Yeah, and you can't really do that here because you're taking a value between -1 and 1 and you're multiplying it by a number like 5.
Right.
So it wouldn't move. It would just jump to this new location and it would just sit there as long as you were holding the right arrow key. But by translating it and changing it over every single frame, relatively sliding it, now you're going to get motion.
You got it.
So I already see where you're going.
So if I come in here, once again, start typing out transform because I want to talk to the transform component, and then dot, now instead of position, I want to come into translate.
Gotcha.
Now, very important. Make sure, for those of you that are new to working with code, that you pay attention to what kind of an element is that we're dealing with. Is it a property that we're going to set? Is it a function that we need to pass information to? Because a few minutes ago you saw how we could type transform.position equals, and in this case it is a function where you'll say transform.translate, and then we'll do an opening parentheses because we now need to feed it information.
Right, this is not a property we're setting.
Exactly. So what we're going to do is we're simply going to tell it, now we're wanting to move what is going to be left and right. So I'm going to use a vector3.right, and we'll talk about that in just a second. I'm going to multiply that by amount to move. There we go.
Okay.
So amount to move contains, if we need to move left or right. Then I'm turning around and I'm telling this guy to translate, but check this out. I'm telling him to translate, I'm using a vector3.right. So this is already set up for us. If we wanted to, we could visualize this as a new vector3, and since we know that left and right is x, and this is all based off of the direction that we're pointing by default when Unity starts up with the camera. Okay, so of course, if we start flipping things around, yes, you're going to end up with these meaning different things.
Right.
Okay, but if I said move 1, 0, 0, I'm telling this guy to translate in x, but relatively, I'm not having any effect on y or z.
Sure.
Okay, and if I put a -1 right here, I'm going to be going in the other direction. Well, amount is going to just contain our -1 to +1, and if we multiply -1 by 1, we're going to get a -1. So
Right.
we'll go the one way, and if we get a +1 multiplied by +1, we'll go the other way. So very clean way of representing our vector3. Okay, so with this setup, everything's looking good, but we're going to have a problem. Let's go back to the comment up here. Update is called once per frame. I'm going to be running at about 5,000 to 6,000 frames a second. Let's analyze what's going to happen here.
You're going to take off like the speed of light.
Thank you. We're going to be moving. So let's go ahead and save this out. Let's jump back over here into our game, and let's see. We might want to position ourselves
really, really far away.
All right, that's pretty good to start out with. Let's go ahead and hit play. So now, if I was to hit the A or the D key, there's our guy. Now I'm just like tapping, just barely tapping. But if I was to hold it, and let's get focused back to our game panel.
Goodbye.
Zoom. Oh, there he goes, way away, and zoom. He goes back the other way.
It's like probably faster than the screen can capture.
So that's a good point. So do we really want that to be the speed in which he's going to move? No.
Yes, we want people to be that elite when they play the game.
Now, of course, that means that somebody may think, oh, I need to select this guy and come back over here to my player speed, and yeah, let's change it to something like 0.1, and then let's manipulate it. So, ooh, look at that. Nice and smooth. No, we don't want to do that. What we want to do, leave this guy at 5. Mm-hmm. And we want to define a speed in which this guy's going to move that will be consistent across all machines that are capable of playing your game. Because let's say that you happen to have a machine that is a generation behind mine, but it's still within specs for running the game.
Sure, if you're going to be moving slower because you have a slower update.
Absolutely. So I might have 5,000 frames per second that I'm running at, and you might be running at 1,000 frames per second, but surely there's a way for us to come up with a consistent speed that we maintain. And there is, and it's actually very simple.
So it's like a way to bypass the speed of the processor? Is that what you're getting at?
No, it is a way in which we will be able to say, this is the amount that I want us to move over 1 second. Okay. So now notice how we've just decoupled ourselves from frame rate, and we're now discussing real time.
Gotcha.
And here's how we do it. I'm going to jump back over into Visual Studio, and I'm going to take and multiply my, so we take, so we've got our, well, let's just jump back up here to our amount to move. We've got our positive 1 or negative 1, multiplying that by our player speed. I'm going to multiply that by one more thing. So times, I'm going to use time dot delta time. Now what this does is this is going to basically be a number that when multiplied by this, we will then have a much smaller amount to move. But the fractional value that's used to multiply by this is a value that enables us to move this amount over 1 second.
So now you're basing it off of physical time, which you can't even have physical time. You're basing it off of time as opposed to CPU cycles.
That's right.
Number of seconds as opposed to...
If you have a slower machine than I or a faster machine than I can still... I can still rest easy at night knowing that my player is still going to move that same distance over 1 second on both of our machines. So by simply putting this in, saving this out, jumping back over to Unity, you'll notice our player speed is still 5.
Yeah.
If I hit play, look at that.
So in a way, you kind of have bypassed the concept of CPU cycles, at least in terms of them affecting the motion of your player.
Right, because think about it. As let's say my frames per second start going faster or start going slower, that time dot delta time, it's adjusting.
Right.
So that I have a consistent amount that I'm guaranteed to move over 1 second.
Very nice.
So the other thing I want to point out before we wrap all of this up is that as I go left and right, you'll notice
a bit of smoothing.
You'll get that. That's that smoothing I was talking about. That doesn't really have that old arcade feel. I mean, not back in the 80s when I went to the arcade.
It was linear. That's not linear.
It would snap. It is wham.
Yeah.
So let's jump back in here, and let's just take a quick advantage of the get access raw, so we don't have any of that smoothing in place, just so that we have seen both of the functions in action. So we'll go ahead and save. We'll jump back over in here and hit play. And so now when I hit left and right, look at that. So
gotcha. I see what it's getting at. It's kind of, without using RAW, it's kind of a way to simulate an analog stick, because there's going to be that moment of time when you go from full right back up to the 0 position.
And depending on your speed in which you're doing it.
It's kind of providing that when you're tapping keys.
Here's the nice thing. Maybe I think that the speed I'm going right now is a little too slow, so without having to jump back over to code, I can come in here and I can make updates and see what I think feels good. Just as long as, don't forget, the number you put in here does not stay in there when you hit stop.
Right.
Man, I've had that burn me in the past where I've made adjustments to several things. I'm like, ooh, that's perfect. And hit stopped and then moved on. And then come back and hit play. I was like, why is it wrong? Oh, man, I did that while I was actually.
Change it while you're not running.
That's right. But it's an excellent way to test numbers. So if I now come back over here, ooh, yeah, nice and snappy. So I can get a good feel for that. Mm-hmm. So, all right. Let's see, how long have we been going? We've been going 20 minutes. And I know it's late at night. You want to play with a little bit of a challenge?
Sure.
All right. Put you on the spot here.
Uh-oh.
What if I wanted him to rap? So he goes off and all of a sudden he pops back in on the other side.
Okay.
Or we go this way and suddenly he pops back in on the other side.
Talking some sort of an if statement?
Okay. I love it. So we're going to start out with an if statement. Zach's like, all right, this is absolutely no fair because this is not planned at all. What are you doing? All right. So,
this is not in the notes.
So the if, my notes contain the 2 lines we just typed. Awesome. So if statement. Actually, you know what? We could come in here. Good habit for you guys out there that are new to coding to get into is throw comments in. So single line comment, 2 slashes. And I can just say amount to move. And then I could come over here and jump in and say move the player. And now I could say
Rapping.
check. Okay, we can just say wrap. That's what Zach said. Zach's in charge now. All right, Zach.
Now, I'm not much with syntax on
no
programming.
worries. It's all good. We're all just here to have fun.
But it seems like if the game is actually centered up right on the center axis, so the middle of the screen is 0. Mm-hmm. If you slide all the way off the screen, as soon as that happens, you could say if your position is greater than this value, couldn't you just multiply it by a negative value to snap him over to the other side?
Okay. Well, let's play with this. First thing I would do would be to come over here and physically
get that location,
get that number.
Yeah.
Now we can do this mathematically because it's an orthographic camera, and there's a very simple equation that we can use to extract pixel-wise what will be our left and right bounds of the screen. Something we can play with a little bit later because I think it goes kind of outside the scope of super simple videos.
Sure.
But let's push them over. So about right. So that's got negative 7.4. I'm looking at the transform component in the inspector.
Yeah.
So let's just say negative 7.5. Let's go on the other side and make sure that's a positive.
7.5.
It is. So we're going to be using 7.5. That's our base. So let's go ahead and put him back at a nice little 0 value. So now that we have some numbers, you want me to say if? Mm-hmm. Well, if what?
If our x position...
Okay, so we would say transform dot position dot x. So now we're looking at that particular element.
Now, what we want to know is if it's greater than... Well, I mean, okay, technically speaking, just in math terms, I want to know if it's 7.5 units away from 0. To the left or the right.
Okay.
I mean, you could do that with two ifs or like an FLs to check in both directions.
Yeah, let's keep it simple. Let's do that.
Okay. Then you could say if it's greater than 7.5, is that the number we chose?
Just since I was dragging left, let's just go with if it's less than or equal to negative 7.5. And I'm going to put an F in there to denote that this is a float. Okay, just so that doesn't see it as a double.
Now we want to assign a new position to it, which will be taking the original position and multiplying it by negative 1.
Okay, so transform.position is...
times equals, can you do that?
Okay, well, we want to do a new vector 3.
All right.
And in this case, I want to keep things very simple.
Yeah.
So I'm actually going to, since we're using a... I'm using less than or equal to.
Sure.
So I'm actually going to put it right inside. I could take the equals out and do the multiplication, but I want to keep everything just black and white for those that are watching that may be completely new. So what if I said move him to 7.4? So that would be just inside.
Right.
On the right hand
so you just
side.
see a sliver of it.
So, which would look good because you should see that sliver because he's just sliding back on.
Right.
So if we did that, Now, what would I want to come over here and put for my Y and my Z value?
Whatever they're already there. So
whatever they're already that you talking.
Yeah. You're rubbing off on me. So transform.position.y and .z.
Absolutely, good job. So we'll throw those guys in there, and then we can say else if. Now again, get transform.position.x is.
You just go in the other way. So this would be greater than or equal to
7.5
right.
F. So if that's the case, and then once again, all right,
just copy that
too
line
much
of code.
typing.
Yeah.
Copy this line of code and paste that line of code. And let's just jump over here and say now he's going to be a negative 7.4 just to pull us right on the inside. And again, we could definitely do the multiplication.
Sure.
But it's a lot of extra stuff to type in.
Sure.
Keeping it simple.
Now, I'm not suggesting we do this. We'll keep it very simple. I just want to kind of theorize with you.
Sure.
Is there a way you can pull the absolute value of the x position out so you can just say if the absolute value of the x position is greater than 7.5 so you don't have to have two different ifs? Because really, in the end,
well, you could just have one if, and put an or in here.
Okay, all right,
and such as that, and then put the other check, and then take the equals out of both of them, and then do the multiply it by -1, and then you could simplify it down. So now that we have this in place, you looking at it, you happy?
So far, yeah.
Okay, so we'll go ahead and save it, and let's see if we have some wrapping ability. So we'll simply hit play. So we're moving back and forth. Let's hit stop real quick and bump up our speed. I like the faster speed. All right, now let's see. Looking good. All right, you ready? Huh?
Ready.
Ready.
What do you got? What do you got?
Oh,
there we go. Looks like we have wrapping.
So it looks like we just have natural wrapping.
Nice.
Good job, Zach.
Cool.
Outstanding. So, and the key thing here, look how easy it was.
It's very easy.
Very simple. So now we have the ability to interact with our player in the scene. Any questions?
No, I think I'm good to go here.
Okay. Well, with that is going to wrap up this video. I believe coming up soon, actually, I have no notes about what video is coming up soon. Sometime very soon, I think it's even in the next video, we are going to start on the projectile so that our player has the ability to fire.
You'll see when we get to the next video.
So that wraps up this video. Thanks, guys.